Hello everyone. Now discussing about the Wlan architecture. Now, as you see, coming to the diagram, I'll be explaining like step by step what all happening to this diagram itself. Yeah. Now, what exactly happens like when we want to configure something on the VLAN, like say how it happens like from web UI to user space, then to kernel space and hardware. Now, in the diagram, as we can see, to configure an AP, we will be doing it either by local UI or from the inside also we can do to configure the things. Now, let's take an example. Like we want to change the SSID name and the channel. Then we click on apply in the web UI or local browser. We'll configure the things and we'll click on apply button. So it has to be applied in the AP. For that, how that it will be happening is like when we click apply, then it will send an HTTP request. Like it will be sending an HTTP packet to the light TPD web server here. Like this web request, it will be sending. In this, it will be carrying the configuration data. Then this HTTP packet will be reaches the device and goes to the light TPD server as mentioned. Now coming to light TPD, like I say small and fast web server, like usually used for the embedded device like things like routers and APs and the things. And what it will do is like it will receive the HTTP request from the browser and will be passing them to the program that can handle these things. Now that program is the CGA. Now the program. Next, the CGA execution. The now CGA stands for Common Gateway Interface. Now the light TPD web server will be running a program to handle this request CGI. Then, so we, request. So when we click apply in the web UI, right, light TPD starts a CGI there. Now this program reads the data sent from the browser. For example, it reads the new SSID and channel as we are configured above, etc. Then, but this program does not have direct access to hardware or drivers. Then it has to then it will be talking through UBus. It will communicate through UBus to config. Now, talking about the UBus, UBus is an internal message bus used for communication between the process, like say intercommunication process, as you see in the OS thing. Like it is mainly used as a publisher and a subscriber mechanism. Like think of it like if something is changed in .c file, and some programs would have been subscribed to .c files, and the UBus will be like a centralized thing, and it will be notifying the subscribers that something have been changed in the particular C file. So the CGI sends a message over the UBus saying like something like the user changed the Wi-Fi configuration. You have to update this to whichever the subscribers they have done to it. Now this message will be going to the config D now, which is the configuration daemon. Actually, there will be the Unix socket which will be establishing communication to the from the CGI to the config D, not exactly to config D. It will establish connection to UBus, which will communicating to all the programs running. Now, config D will be managing configuration changes. Like it takes a request from UBus, understands like what configuration is being changed, and it will make sure the configuration is stored properly. And now coming to this library UCI commit thing, coming to the thing like UCI stands for Unified Configuration Interface. Like in if you see in OpenWRT, almost all configuration will be stored in the text files, right? Under say etc config. Now for Wi-Fi, the main file is etc config wireless, where all the configurations will be written for the Wi-Fi. So when a config receives a request, it uses a libuci to write the new settings into the UCI files and commit them. These are the UCI files. It will be modifying that, and commit means saving the changes like permanently. Like until now, as we can see, we have new configuration saved in the etc config wireless files. But to apply changes, we have to say reload the thing. Yeah, sorry, trigger mean the system tells the network services like configuration has changed, so you have to reload and apply the new settings. Then after here trigger reload will be triggered, and then after here netfd in the network is a network interface daemon. Like it is to manage network interfaces, including Ethernet and Wi-Fi. Like when it receives a reload signal, it will read the user configuration files again, and NetFD takes the configuration from etc config wireless and converts it into actual configuration files that the Wi-Fi system can use. For Wi-Fi, this usually means generating a host apd.config, okay, host apd.config. Like this file is created dynamically, like based on the configurations we have made earlier. Uh, if this file is generated, the system sends a reload command to the host APD process. So now talking about the host APD, now host APD is a user space program that handles things like beaconing, authentication, association, security, and handshakes, uh, etc. When host APT receives the reload signal, right, at that time it will read the new configuration file and updates its internal settings. But host APT also still cannot talk directly to the kernel level. So it will be communicating to the kernel level through NL80211. This is a netlink interface which will use it for the communication from user space to the kernel space and come and discuss about NL80211 is a as mentioned is like a netlink interface between the user space and kernel. So here host API sends commands to NL80211 to the kernel like what are the things we have been changed earlier. Inside the kernel space we have config 802 CFG 80211 and make a and Mac 80211. And talking about CFG 80211, like it is like the configuration layer. Uh, it handles things like setting channels, like setting, transmitting power, etc. And mainly about the regulatory rules, what are the channels allowed, and like that type of things. And coming to the MAC layer, is the MAC layer of Wi-Fi. Like it handles frame processing, queues, retransmission, etc, that type of thing. Like here, the actually the frame will be made. What happens is like from host APD, the only the template of the thing will be coming. Suppose if we take a beacon, only the template will be coming. Here, the all fields will be filled in that beacon template, and the actual frame will be made in this Mac 8.11. And now coming to Wi-Fi driver, the driver will be specific to the hardware vendor, like say Qualcomm, Broadcom, etc. The drivers are used to convert the command to hardware understandable. Then we have the firmware running on the Wi-Fi chip. The firmware controls the actual radio hardware, like it handles scanning, time control, etc. When everything above is configured correctly, then the firmware and hardware will be start operating in the new settings. Now, talking about like control plane and data plane, like it's like everything from the web UI to host APD. Like from here, web UI to this process, like host APD, like configuration, and control message. It is in the control plane. Now it's like configuring the system and configuration behavior. The actual user data, like sending the packets or Wi-Fi through the data plane. That data plane is mainly handled by the Wi-Fi chip, firmware, driver, and kernel type of kernel. So control plane mainly sets the rules, and data plane moves the real traffic. We can select that. And now uh, coming to the product view of the Wlan access point, so you can connect to a AP flow inside that. And talking about the main components inside the Wlan AP, uh, as mentioned, the first component is like the host CPU. Like this is the main processor of the AP. Like it runs Linux, runs services like TPD, config.d, netfd, and host APD as we have seen, and handles all management and control logic. And the host API is like mainly responsible for the control plane. It does not forward every packet in software, but it decides how things should work and programs the rest of the system. And the second thing is like the wireless chipset. Like this is a specialized hardware chip, mainly that handles Wi-Fi radio operations coming to, and it sends and receives frames over there, like handles time critical operations and often does data processing. Like the ship is mainly responsible for the data plane, meaning the actual user traffic flow. The third component is the firmware. Like the firmware runs inside the wireless chipset. Like it controls the radio and handles scanning, rate control, and many 802.11 operations. The firmware works together with the driver and Mac 802.11 to make sure the packets are transmitted and received correctly. And now see how a wireless line connects and send a packet and sends data like step by step we can see if you see like this. Then first the client sends and finds the SSID. Then it sends the authentication and association request. Now these are handled by the AP using host AP thing and the driver and the firmware. Now host AP will be checking with the security settings regarding the handshake. And once everything is successful, then the client will be connected to AP. After the client is connected, right? When it sends the data, the AP frames go from the client over the air to the Wi-Fi chip. Then after the firmware and driver receive them and like pass them into the system, then the kernel forwards them to the wire network. Usually there will be a bridge. It will forwarding in the bridge. In the opposite side, the data from the from the wired network is sent to the Wi-Fi chip and transmitted over the air to the client. Like this, the data. Right? And talking about the difference between the standalone API and the cloud API. In standalone API, right, all control and data plane functions are local. If we log into the device directly using Web UI and CLI and configure it, and it makes all the decisions by itself, like configuration management and forwarding, all are handled inside the same device. In a cloud-managed API, the data plane is still local. That means user traffic does not directly from the AP to the network without going through the cloud. But a big part of a control plane is centralized here, and configuration, monitoring, policy decisions, and updates are done by the central controller or cloud system in this. The AP talks to the cloud management and gets its configuration and report status, but still uses its own hardware to forward user traffic, and all those things are documented here. Mm, Thank you.